Sorry, my mic was on mute. I was asking the density and temperature. What do you know about density and temperature so far? Any formula, in terms of theory, anything?
Like density means how compact an object is, how
Yeah.
closely the molecules are packed in a substance.
Okay. Sereno, do you have anything else to say? Or do you
I
have
would
any formula in mind?
yeah, mass or volume.
Okay. And temperature?
Uh, you want me to define temperature?
Whatever comes to your mind. I'm not expecting any.
Um, well, temperature is just the kinetic energy of all the molecules.
Yes, very good. This is what I was expecting. Temperature is basically the average kinetic energy of the core of the particle, or in other terms, in physics, we could say intensity of hotness or coldness of an object. Whereas density is mass over volume and compactness of an object again. How much volume does that particular object consist of? So we're going to discuss these two physical terms in this chapter, density and temperature. And we know that okay, when it comes to the discussion of all these solid, liquid, and gas, when we discuss the densities of the object, solid has the most density, then liquid, then gas. And the reason behind this is in terms of density is because the particles are most compact in solids, that they are closely packed with strong intermolecular forces in case of solid, and then these forces tries to be we not tries these forces weaken up for liquid and gas only. Okay. So, and when it comes to liquid, they are loosely packed and their intermolecular forces are a bit weak and loosely packed, so their density decreases. And then when it comes to gas, intermolecular forces are very weak to almost zero. And packing तो उनका कुछ होता ही नहीं है, they are further apart. अब डेंसिटी वर्सेस टेम्परेचर को डिस्कस करें. I have not entered into the chapter yet. अब हम जनरल डिस्कशन करें. Since we have discussed that the density of an object versus the temperature, they have a very close relationship in context with each other, that whenever we will increase the temperature of an object, obviously and clearly, the kinetic energy of the particle would increase. And the object will start to become less dense. Why is that? When the kinetic energy of the particle would start to decrease, start to increase, start to going, they will start going further apart. And when they will go further apart, spaces between the particles would increase and the intermolecular forces would decrease. In this way, they will start to become less dense. So somehow we're going to discuss that relationship as well, that how density and temperature is interlinked to each other, where solids, liquid, and gases have their respective densities, and the densities start to decrease from gas to sol sorry uh start to decrease from solid to gases due to the intermolecular forces and the compactness of the part. Basically, intermolecular forces is basically what deciding the compactness of the object. So जब अगर वो decrease होगा तो उसकी values भी क्या होगा, change हो जाएंगे. Okay. अच्छा. You might have seen in the theory as well कि उन्होंने उनके basic concept discuss किया हुआ है. The example, the definition is exactly the same given by जो हमने दी थी. Tells us about its volume, the substance which has closely packed atom has more matter in a fixed volume, therefore it is denser solid, whereas when it comes to solid, like metals are denser material because they have बाकी solid liquid gas की properties इन्होंने discuss किए हुए हैं यहाँ पे, and then we formula discuss किया where it's mass over volume, and mass as a unit of grams or volume centimeter cube, and इनके volumes vary कर sorry volumes कह रहा हूँ, इनके units accordingly vary कर सकते हैं. We know that के mass किलोग्राम भी आ सकता है, volume का meter cube भी आ सकता है, liters भी आ सकता है. There could be certain formulas that we can use for the densities. और जिसका डेंसिटी जितना ज्यादा होगा वो उतना ही ज्यादा हेवियर एलिमेंट होगा. Go ahead and review this example, and then we will go to the how to find the density of the liquid. I hope आपने ये इतना पोर्शन तो उसको स्टडी कर ही लिया होगा. If not, इसको जल्दी से देख लें, and then we'll go to the next part. What is the formula of density for liquid? Clearly हमारे पास सामने diagram बनी हुई है. We could easily refer to that. The liquid whose density we're going to measure, first we'll pour that into a measuring cylinder. We will note the volume of that liquid from there, and then first we will measure the empty cylinder. We will note the mass of it, and then we'll pour the liquid into it, and we will measure the mass of liquid out of it. Then we will subtract both the masses in order to find out the mass of liquid and volume with from the measuring cylinder. So this way we will get the density of the liquid, mass over volume. This is the mass of empty cylinder. Suppose it came out to be 10 grams, and by putting liquid into it, it becomes 110 grams. What is the mass of the liquid? Mass of the liquid is only 100 grams. So we'll put that here, and we will note the cylinder volume of the liquid from the measuring cylinder. We'll put this into here, and we will find the density of the liquid. Greater the density, उतना ज़्यादा वो dense होगा, it will settle down easily. अब मैंने उसको वो अंडा खिलाया, सेब खिलाया, तो कुछ खाया नहीं बच्चे ने. जिसका लिक्विड की डेंसिटी कम होगा वो लिक्विड उसके ऊपर one above the others. For example, you must have seen that example के water glass. If you take a glass of water and put some oil onto it, so oil उसके surface के ऊपर क्या रहेगा? Stay करेगा, and the liquid will be behind it. Similarly, even if you try to mix it, liquid क्या oil उसके अंदर mix up होता है? Does it mix up?
No.
Because they have a difference of density. तो उन्होंने यहाँ पे basically यही discuss किया हुआ है कि इस तरीके से हम लोग how can we go for finding the density of the liquid. अब आते हैं density of a regular shaped object and versus density of an irregular shaped object. अब जो regular shaped object होता है उसका तो हम easily formula होता है volume का कि length into base into height. ठीक है, ये हमारे पास shape बन जाएगा. उसके अंदर हमारे पास if this is the regular shaped cube, तो हमारे पास ये हो गया बेस, ये मेरे पास क्या हो गया हाइट, एंड दिस इज क्या हो गया लेंथ. यू कैन गो इन ईदर वाइज. हमने बेसिकली उनको मल्टीप्लाई करना है, वॉल्यूम टू लेंथ इनटू बेस इनटू हाइट. इट डजंट मैटर व्हिच इज बेस और हाइट, और वॉल्यूम में कंफ्यूज होने की जरूरत नहीं है कि इसमें कोई मिस्टेक तो ना हो जाए. हाँ, बेस क्लियरली हमारे पास ये होता है, लेंथ हमारे पास स्ट्रिक्टली ये लेंथ होता है, ये बेस होता है, और वो हाइट होता है हमारे पास. बिकॉज दे आर सर्टन थिंग्स जहाँ पे हमें एरिया को कैलकुलेट करना होता है, वो जस्ट बेस इनटू हाइट की इक्वल होता है, तो उसमें थोड़ा मिस्टेक आ जाता है हमारे पास. एनी हाउ, for regular shape object we will measure the length, base and height of that object, and we will find the volume of that object. But if we have an irregular shape solid substance whose volume and density is to be measured, उसमें हम क्या करेंगे? Same rules. What is the formula for density?
Mass per volume.
Mass over volume. So if I have something like this mass, I will measure the mass of it using the my balance. And then in order to find out the volume of this object, I will take a cylinder, measuring cylinder. I will put a known volume of liquid into that cylinder. For example, 10 centimeters cube. Now I will put the substance whose volume is to be measured into this, and I will look for the rise of volume. For example, now the volume is 13 centimeter cube. So what would be the volume of the object now? Before putting the object, the volume was 10 centimeter cube. After putting the object, the volume came out to be 13 centimeter cube.
So the volume is 3.
So the volume of the object is only 3 centimeter cube. There are two ways through which we can find out the volume. The very first and very easy is final minus initial kar le, or we could just look for the rise of liquid. That would be the volume of the object. ठीक है, दोनों केस में हमारे पास हो सकता है. हम लोग फाइनल माइनस इनिशियल कर लेते हैं, या फिर सिंपली राइज ऑफ लिक्विड देख लें. दैट वुड गिव अस द वॉल्यूम ऑफ द ऑब्जेक्ट, एंड देन अगेन वी विल पुट दिस इनटू द फॉर्मूला. डेंसिटी का सिंबल इस तरह होता है हमारे पास, mass over volume, whatever we have calculated the mass through the balance, and the volume from here we will put into the formula, and we will find the density of an irregular shaped object. Is there anything I could help further explain how to find the density of a regular or irregular shaped object?
Yeah, I get it.
Same, I
Hamna?
get it too.
Okay. Just for the record, did I, मतलब हमने ये discuss कर लिया है ना कि this method that we have discussed is known as the displacement method. जिसमें we measure the mass of the object using the balance and then put it into the liquid and look for the rise of liquid. This is known as the displacement method. Now the example that they have discussed here is first K. Mass of the rock is 8.72 grams. It was immersed in a measuring cylinder. What is the initial volume here? Let's see what is the initial volume. It's 11, 12, 13, 19. कितना बना, हमने लोअर मेनिस्कस देखना होता तो 18 बनेगा हमारे पास इनिशियल वॉल्यूम, एंड आफ्टर पुटिंग द वो हमारा फाइनल वॉल्यूम को बन रहा है 41, 42, 43, 44, 45, 46. 46 बन रहा है हमारे पास. देखो लोअर मेनिस्कस लेना होता है हमने हमेशा. द डायग्राम जिसके पास कलर्ड बुक है वो क्लियरली देख सकते हैं कि उसका लोअर मेनिस्कस 46 पे टच कर रहा है. हम ना, do you see that in your
Yeah.
book?
Yeah.
Lower meniscus. Basically,
Yeah.
we see this concave shape, convex shape of liquid. तो उसमें जो ये जो bottom वाला section होता है ना, इसको lower meniscus कहते हैं. We always look for this lower meniscus. So initial volume कितना था हमारे पास? 18. Final volume कितना आया? 46. So what would be the value? 46 minus 18 कितना हो जाएगा? वो तो बाकी सब कुछ तो यहाँ पे लिखा ही हुआ होगा. So the mass is given as 80.52. The initial volume is given as 18. Final volume is given as 46. Change of volume is 28 centimeter cube. Mass divided by volume would give us the volume of the object using the displacement method. Here we have the volume of a regular shaped object. Length is given as 21. वैसे जो मैंने correction करवा दी थी ना, if I'm not wrong, exact length, base and height बनती क्या है? हाँ मैंने करवा दी. Okay. यहाँ से आपको और आइडिया होगा. Length is 21.6, base is 10.2, width basically and height is 6.35. Regular shaped object का volume किसके equal होता है? Length into width into height. All of it is multiplied. अच्छा अब देखो हमने इनके units क्यों change किए हैं? Because mass was given in the base unit which was 3.30 kilograms में दिया हुआ था. That's why हम लोगों ने बाकियों को भी किसमें कन्वर्ट कर लिया, बेस यूनिट्स में, दैट वाज मीटर्स के अंदर हमने उसको कन्वर्ट कर लिया। 21.6 सेंटीमीटर इज बेसिकली 21.6 into 10⁻⁻² meters. ठीक है, all of this multiplied together, this would give us the volume of the object. The mass is given as 3.30. We'll divide the mass with the volume and we'll get the volume of a regular shaped object. And lastly, we were supposed to find out the volume of a liquid. The mass of the empty cylinder is given as 145 grams. After putting the liquid, the mass came out to be 205 grams. So what would be the mass of liquid? Hamna, how would we find out the mass of liquid?
We will measure it like by the mass. Wait.
Yeah, we'll
Um,
subtract the mass with the liquid of the cylinder minus the empty cylinder. So the 205 minus 145 would give us the mass of the liquid only. What was the volume given? 60 milliliter. So we do not need to convert any units anywhere because already वो base units में given नहीं है. हम सिंपल उसको formula में put करेंगे. So 205 minus 145 is 60 grams and volume is 60 milliliter. 60 divided by 60 is 1 grams per milliliter. And ये तो basic density उसमें find out किया हुआ है. Everything is already given in the question. The mass is given as 500 grams and the volume is given as 5 centimeter cube. ठीक है, so mass of this 500 grams fund density, so 500 divided by 125 क्यूब है. क्यूब का वॉल्यूम किसकी इक्वल होता है? क्यूब एक रेगुलर शेप्ड ऑब्जेक्ट होता है एंड उसकी ईदर साइड्स क्या होती हैं? इक्वल होती हैं. सो 5 into 5 into 5 would give us 125 सेंटीमीटर क्यूब ऑफ वॉल्यूम. क्यूब का वॉल्यूम दे देगा. सो मास डिवाइड बाय वॉल्यूम इज 4 grams per centimeter cube. Kinetic energy is related with the temperature of the object. So if the temperature of the object is increased, so does the kinetic energy of the particle. तो वही points हमने further on discuss करने हैं. उन्हीं के context में all of the states and everything is discussed. कि what is it? So if without reading into this topic, relationship between the motion of the particle and temperature, what is coming to your mind? That what we are going to study in this topic. Do you have?
Maybe
हाँ.
maybe if you increase the temperature, the motion increases, and if you decrease it, vice versa happen.
What इसके against what would it affect? How would it affect the state of matter? Hamna, increasing the temperature and decreasing the temperature. How would it affect it?
Well, like in each state, the particles would be differently arranged, and like
Intermolecular
the different
forces को हम
states will
discuss कर
have,
सकते हैं. Yeah, we can discuss
yeah,
intermolecular forces.
and the different stages will have different kinetic energy.
Yes. So states पे major question is, so उसकी वजह से state में क्या आएगा? Change आएगा. Because increasing the kinetic energy of the particle would increase the since the kinetic energy of the particle is increasing, so does the intermolecular forces weakens up. They go further away from each other. So there is a change in the state of matter. And the opposite happens when we decrease the kinetic energy of it. So when the kinetic energy, similarly, यहाँ पे हम relationship भी कह सकते हैं. If a the numerical comes under this or the MCQ comes under another point, okay, what would be the effect of it on if the kinetic energy of the particle is less, what can we say about the temperature of the object? हम simply क्या कहेंगे? If the kinetic energy of the particles are low, this means the temperature of the system is also low. There is also a relationship between another thing. You guys remember internal energy? इंटरनल एनर्जी सम ऑफ क्या था? ऑल फॉर्म्स ऑफ एनर्जी था, ठीक है। इंटरनल एनर्जी, टेम्परेचर एंड काइनेटिक एनर्जी, दे आर ऑल रिलेटेड टू ईच अदर, ठीक है। So if someone says that kinetic energy is increased, this means temperature is increased. This means internal energy is increased. They all are related to each other. Can you keep this in your mind?
Yeah.
Yep.
अच्छा, प्लाज्मा क्या है? What do you have in mind with respect to plasma? What is plasma? Plasma is the
Plasma is like the
fourth state
fourth
of
state
matter.
of. Excuse me, sir?
It's the fourth state of matter. Yes. Achha. So let's start with the fourth state of matter, which is plasma. And ज़्यादा बड़ा होगा। Okay. Plasma consists of, पहले definition है उसकी, let me use a lighter color. Plasma consists of positive ions, free electrons, and neutral atoms. इनका combination is known as gaseous state. Gas को आप जब extremely heat up कर देते हो ना, so this state came into existence, जिसमें ions भी होते हैं, positive, negative, neutral, सब कुछ exist कर रहा होता है at the same state. Especially in gaseous state, gas state के बाद जो है ये चीज वो transfer होती है. Usually plasma exists at a very high temperature and high pressure at both. By using a high electric and magnetic field, a substance can also be transformed into plasma. There's a lot of plasma in the universe. Universe के अंदर basically plasma ही discuss होता है. Plasma exists in the sun, star glows because of plasma, cause वहाँ पे बहुत high pressure and temperature है, तो वहाँ पे plasma easily exist कर सकता है. Nebula and auroras at the south and north poles are due to plasma. वो जो color forms होते हैं ना, green and blues जो हम देखते हैं sky के ऊपर Arctic region के अंदर, that is also due to the plasma. Neon light glows because of plasma. Lightning in the sky is also plasma. तो ये सारी examples हैं. If examiner ask in the MCQ or in the short question, you can refer to all these, which is the live real life examples के जो plasma की justification देते हैं हमारे को. Plasma वही अब वही
So
point उन्होंने discuss किया हुआ है. Yes.
is fire plasma?
No, fire is not a plasma. Plasma only exists when gas is at such a high temperature and pressure that everything in the gas becomes either ion or the neutral atoms exist. So temperature simple fire के अंदर plasma तो exist नहीं कर सकता ना, because it does not have that temperature and pressure. ये thousands and thousands of degrees Celsius के ऊपर and a very high pressure जाके generate होता है.
So what
Not
state of
at the usual
fire
stage.
is like at what?
At a very high temperature and pressure. They do not normally exist
Okay.
in the
Okay.
मतलब रियल लाइफ में प्रैक्टिकली हमारे अराउंड एग्जिस्ट नहीं करता, लाइक मतलब हमारी एवरीडे रूटीन के अंदर इट एग्जिस्ट एट वेरी हाई टेम्परेचर एंड प्रेशर. अच्छा, ये आगे वो जो आपका क्वेश्चन था ना, वो भी यहाँ पे डिस्कस है कि प्लाज्मा इज अ गैस दैट हॉट, ब्राइट एंड हाईली आयनाइज्ड, और ये सिर्फ हाई टेम्परेचर एंड प्रेशर के ऊपर ही होता है. नॉर्मली फायर के अंदर हमारे पास क्या नहीं होता हमारे पास, ठीक है. फायर को हम एज अ स्टेट तो नहीं बात कर सकते ना. स्टेट्स ऑफ मैटर तो हमारे पास ये चार ही होती है ना. तो फायर वुड somehow come under the category of gaseous state, हम लोग डिस्कस कर लेंगे उसको. These characteristics together make it a different from the gas. 99% of visible universe is made up of plasma. That is why plasma is often called the fourth state of matter along with solid, liquid, and gas. 99% of visible universe is plasma. Okay? When a gas is heated continuously, kinetic energy of the gas molecules also continuously increases. Due to it, reactive molecules forces keeps on decreasing as molecules go away from each other. The molecules and atoms start colliding with each other powerfully due to the electrons of atoms are removed and atoms become positive ions. Because very high temperature pressure की वजह से electron in their outermost shell जो है वो transfer हो जाते हैं. Sorry, they leave the outermost shell and they become ion. Due to it, electrons of अच्छा लिखा हुआ है उसने आगे, हमने ये डिस्कस कर लिया. This ionic state of matter is called plasma. If there is no ionic state existing in there, we will not call it a plasma. It can be highly conduct current because it has free electrons and moving ions. Baaki definition and की difference between motion of the particles. Even though the water molecules in a pot are constantly moving, the moving is not powerful enough for us to notice it with our naked eyes. Brownian motion you might have studied in your sciences. Brownian motion basically was the first section through which we came to know that particles of fluid are always in a state of motion. ठीक है, वही बात डिस्कस करें कि the molecules of water or air we cannot जो है view them with the naked eye, but we know with the help of the Brownian motion that there is a constant motion of particles across it. So even though, however, we observe the water current or water molecules in motion at a higher temperature, when we place this hot furnace of जब हमें वो boiling feel होती है, तो we could see the particles moving, right? Actually, there is a certain relationship between motion of the particle and its temperature. In this section, we will understand this relation. When a material is heated, one of the two things happens. Strength of the attractive force between the particles can decrease and bond between the particles may break as it happens during the melting and boiling process for material. It can speed up the particles and hence increase the kinetic energy of the particle. बाकी ये टेम्परेचर की वो सेकेंड वाली डेफिनेशन भी यहाँ पे लिखी हुई है जो मैंने आपको बताया था कि एज अ मेजर फिट्स हॉटनेस और कोल्डनेस इन टेम्परेचर ऑफ सब्सटेंस डायरेक्टली प्रोपोर्शनल टू एवरेज काइनेटिक एनर्जी ऑफ द पार्टिकल. ये जो श्रीनो ने कल डेफिनेशन बताया था एंड ये साथ में टेम्परेचर की डेफिनेशन है. When we heat a substance, the kinetic energy of its particle increases. That is why the temperature of the substance will also increase. Conversely, we remove heat from a substance, the speed and kinetic energy of the particle will become slower and slower. Or the kinetic energy of the particle would be reduced. That means the temperature of the system is also reduced. We used to discuss किया हुआ है. बाकी उसने वही डिस्कस किया हुआ है. ये जैसे टेम्परेचर डिक्रीज होगा, kinetic energy of the particle भी डिक्रीज होगा. And -273 degree C or -273 degree C जो -273 degree C का टेम्परेचर होता है, that is known as, ये जो -273 degree C है, this is known as absolute zero. At this temperature, the kinetic energy of the particle ceases. Becomes 0. ठीक है. बाकी इंटरनल एनर्जी एंड टेम्परेचर ऑफ सब्सटेंस के अंदर वही डिस्कस जो मैंने अभी आपको बताया कि इंटरनल एनर्जी एंड दीज एवरीथिंग इज इंटररिलेटेड टू ईच अदर. कि इंटरनल एनर्जी इंक्रीज हो रहा है, दिस मींस द काइनेटिक एनर्जी ऑफ द पार्टिकल इंक्रीज हो रहा है, एंड kinetic energy of the particle increase हो रहा है, that shows कि temperature of the system is increased. Temperature of the system increase, and this means internal energy is increased. So somehow they are in a cyclic process, they are related to each other. So जो इंटरनल एनर्जी ऑफ सब्सटेंस आगे सबसे पहले उसने उसकी डेफिनेशन डिस्कस की हुई है. इंटरनल एनर्जी ऑफ सब्सटेंस इज द टोटल एनर्जी possessed by the particle of a substance. Internal energy is the total kinetic energy and potential energy of the particle. Potential energy of the अच्छा, normally students think of कि जी how potential energy is being possessed by the particle. तो वो उसको justify इस तरीके से करते हैं कि if this is a system, इसके अंदर गैस के particles हैं, तो इनकी जो position है, this position justifies the potential energy of the particles. Because potential energy को कैसे define किया जाता है? How do we define potential energy? We have discussed previously.
energy that an object possesses because of its position.
Position, ठीक है, because of its position or height from the surface. तो since जब वो system के अंदर अपनी particular position के ऊपर exist कर रहे हैं, उनके position due to kinetic energy change भी हो रहा है due to the Coulombian, so उनके पास potential energy भी होती है. Potential of the particles due to attractive forces between the particles as well, and these particles can have three forms of kinetic energy. Translational kinetic energy, ये हमने start में पढ़ा था. Translational motion, rotational motion, and vibratory motion. So these three kinetic energies will be possessed by this. In case of ideal gas, it only has translational kinetic energy. Therefore, its internal energy is only due to the kinetic energy of the particle. Ideal gases वो होती हैं जिनकी आइडियल गैस को डिफाइन करते हैं कि जो कि जनरल गैस लॉस को फॉलो करते हैं. दैट इज नॉट समथिंग दैट वी आर गोइंग टू स्टडी इन आवर कोर्स, बट वो कंप्रेशन एंड इसी तरह ट्रांसलेशन, किनेटिक एनर्जीज एंड एवरीथिंग, इन सब रूल्स को जो ना फॉलो कर रहे होते हैं इन ऑर्डर टू अंडरस्टैंड एवरीथिंग ना. सो सच गैसेस आर नोन एज आइडियल गैसेस, जो जनरल गैस लॉ को फॉलो करते हैं, और उनका प्रेशर एंड वॉल्यूम का रिलेशनशिप जो होता है, प्रेशर एंड टेम्परेचर का जो रिलेशनशिप होता है, एंड वॉल्यूम एंड टेम्परेचर का जो रिलेशनशिप होता है, वो आइडियल होता है इन सारा इन गैसेस के केस के अंदर. So बाकी rest of the thing that is written here is already I've explained it, and बाकी आप लोगों को पता है कि मैं सिर्फ हेडिंग को एक्सप्लेन करूंगा. रेस्ट यू शुड सी कि एक्सपेंशन ऑफ लिक्विड विल अकर व्हेन वी विल इंक्रीज द टेम्परेचर. आप जब टेम्परेचर इंक्रीज करेंगे, kinetic एनर्जी ऑफ द पार्टिकल इंक्रीज होगा, द पार्टिकल्स ऑफ द लिक्विड वुड गो फर्दर अवे, एंड व्हेन दे विल गो फर्दर अवे फ्रॉम ईच अदर, तो उनका वॉल्यूम क्या करेगा, इंक्रीज करेगा. They will expand, they will go further apart. This will be known as expansion. तो सबसे ज्यादा कौन एक्सपेंड करता है? जब हम डिस्कस करते हैं सॉलिड वर्सेस लिक्विड वर्सेस गैस में, सबसे ज्यादा गैस एक्सपेंड करेगा, देन लिक्विड, देन सॉलिड. एंड गैस सबसे ज्यादा एक्सपेंड क्यों करेगा? Why would the why would gas be expend the most? What comes to your mind? Why would gas expend the most?
It has more kinetic energy.
No, because they have zero to very weak intermolecular forces. So all of the energy that we're giving to the system वो उसको expand करने में utilize हो जाएगा. No work has to be done in order to overcome the क्या कहते हैं intermolecular forces. Similarly, आप जब हम वेरिएशन ऑफ वॉल्यूम एंड प्रेशर को डिस्कस करते हैं, अब इसमें एक चीज आती है, if temperature is kept constant, if temperature is kept constant, pressure and volume are inversely proportional to each other. ठीक है? Why is that? Because if we would increase the pressure, the collision between the particles would increase and they would go further apart from each other. Due to that, volume हमारे पास क्या करेगा? Decrease करेगा. ठीक है? Sorry, I said everything opposite. Sorry. For example, this is the container. These are the particles. They are further away from each other. But if I have increased the pressure, मैंने piston को downward move किया, now the gas will have lesser space to move. ठीक है? So उसका volume, they will come closer to each other. Volume उसका क्या कर जाएगा? Decrease कर जाएगा. So whenever we discuss all these in context to this one, तो pressure and volume का हमारे पास क्या होता है? Inverse relationship होता है if temperature is kept constant. और अगर temperature constant नहीं है, तो हमें पता है कि अगर हमारे पास टेम्परेचर इंक्रीज करेगा तो काइनेटिक एनर्जी ऑफ द पार्टिकल भी इंक्रीज करेगा, कोलिजन बिटवीन द पार्टिकल्स भी जो है वो इंक्रीज करेगा, जिसकी वजह से वॉल्यूम क्या करेगा? इंक्रीज करेगा. दिस कॉन्सेप्ट ऑफ प्रेशर and volume is only discussed in context to the temperature. If temperature is kept constant, pressure and volume has an inverse relationship. Otherwise, इन दोनों का क्या है? फिर हम वो डायरेक्ट ही होता है. तो अगर हम टेम्परेचर इंक्रीज करेंगे, काइनेटिक एनर्जी इंक्रीज करेगी पार्टिकल की, जिसकी वजह से क्या होगा? कोलिजन रेट इंक्रीज होगा. If the collision between the particle is increased, तो उसकी वजह से हमारे पास प्रेशर इंक्रीज कर देता है. तो so many parameters came into context. So when you will read these topics, you'll get to know all these points which I have just explained. Okay. topic है कि when it comes to the temperature measuring devices, the only thing that comes to our mind is the thermometer. But before getting into that, we know that the thermometer is a device which measures the temperature. ठीक है? Measures temperature. Okay, it's a device that measures the temperature. But there are certain qualities through which we can identify the temperature change easily. And that is the change in the volume. यहाँ पे लिखा हुआ है कि expansion of the volume से, volume expansion of the liquid से, solid से, pressure change से, changes in the EMF and changes in the electrical resistance, we can easily identify that there has been some change of temperature. These are the properties through which we can identify the change of temperature in a particular body. For example, if we start seeing a liquid bubbling, what would come to your mind? Whether its temperature is increasing or decreasing?
Temperature is increasing.
Okay. If we see a solid block of ice melting, what would come to our mind?
If it's melting, then the temperature is probably
If it's
increasing.
melting, okay. So these properties, these are the properties through which we can identify the change in temperature, and such properties are known as thermometric properties. These are the properties through which we identify the change of temperature in that particular substance. So अब उन्होंने यहाँ पे क्या लिखा हुआ है कि I don't know the second heading of the table, but इनको expansion of the liquid we could measure using thermometers. These are the following thermometers through which we can measure. There are only two or more terms which you are not familiar with. One is thermistor, then we have bimetallic strip, and lastly we have thermocouples. Thermistors are the devices in which identifies the change of temperature when ये सब temperature devices हैं हमारे पास, ठीक है? Thermistor is a device जब उसमें change of temperature होता है, its resistance decreases. And what is resistance? Resistance is opposition to the flow of current. मैं basic terms जा रहा, I'm not getting into detail of anything. Opposition to the flow of current. अब एक चीज को आप लोगों ने माइंड में रखना है कि हमने जो टेबल के अंदर ये चीजें पढ़ी हैं, दीज मेंशनिंग जिन्होंने किया हुआ है, इनको मेजर हम किन डिवाइसेस से करते हैं, वो ये है हमारे पास, ठीक है? थर्मिस्टर हमारे पास एक कंपोनेंट होता है जिसकी जो है ना रेजिस्टेंस चेंज होती है विद द चेंज इन टेम्परेचर, एंड रेजिस्टेंस का मीनिंग क्या होता है? ऑपोजिशन टू द फ्लो ऑफ करंट हमारे पास, ठीक हो गया? बायोमेटालिक स्ट्रिप जो होता है वो चेंज ऑफ टेम्परेचर के अगेंस्ट मैकेनिकल मूवमेंट शो करता है हमारे पास, ठीक है? चेंज ऑफ टेम्परेचर is indicated by mechanical movement. मैकेनिकल मूवमेंट कह सकते हैं हम, या एक्सपेंशन के थ्रू, एक्सपेंशन ऑफ द स्ट्रिप होता है हमारे पास, ठीक है? एंड लास्ट हमारे पास जो आता है वो थर्मोकपल आता है. इट इज अ डिवाइस व्हिच शोज टेम्परेचर change in terms of current, EMF. जैसे इसका टेम्परेचर इंक्रीज एंड डिक्रीज होगा ना, इट वुड शो दैट इन टर्म्स ऑफ करंट, ठीक है? अब इसमें होता क्या है थर्मिस्टर के अंदर हमारे पास, these are all the apparatuses that we use to measure the temperature. इनकी प्रॉपर्टीज क्या है कि थर्मिस्टर की प्रॉपर्टी क्या होगा? चेंज ऑफ रेजिस्टेंस पे शो करेगा. बायोमेटालिक स्ट्रिप किस पे शो करेगी? चेंज ऑफ एक्सपेंशन पे. एंड थर्मोकपल किस पे शो करेगा? EMF. सो द सर्कल्ड पॉइंट्स जो है हमारे पास करंट एंड EMF के थ्रू, दिस इज अ थर्मोमेट्रिक प्रॉपर्टी थ्रू विच वी आर आइडेंटिफाइंग द चेंज ऑफ टेम्परेचर, ठीक हो गया? एंड यहाँ पे बायोमेटालिक स्ट्रिप में जो मैकेनिकल मूवमेंट स्लैश एक्सपेंशन है उसके थ्रू हम आइडेंटिफाई करें टेम्परेचर चेंज को. एंड थर्मिस्टर के अंदर हम रेजिस्टेंस के थ्रू आइडेंटिफाई कर रहे हैं कि whether the temperature is changing or not. So these properties through which we observe the change of temperature is known as thermometric property, and these are the devices and these are the properties through which we can identify that. Do you get the point?
Yeah, but what is EMF?
EMF is the voltage जो बैटरीज वगैरह नहीं दे रहे होते. इनके ऑब्वियसली आगे नेक्स्ट कैलिब्रेशंस होती हैं, डिजिटल कैलिब्रेटेड थर्मोमीटर्स होते हैं ये, बट ये पर्टिकुलर जगहों पे यूज होता है. बट थ्रू विच दे शो द टेम्परेचर चेंज, हमें वो पॉइंट्स याद रखने हैं. ओके, दिस टेबल, if you keep this table in your mind, you just need to write the theory according to it. Rest as everything is fine. बाकी हम लोगों ने टेम्परेचर वर्सेस इंटरनल एनर्जी वर्सेस काइनेटिक एनर्जी को ऑलरेडी डिस्कस किया हुआ है. ठीक है. What was, अच्छा, let me ask you a question. What was the relationship between pressure and volume? Pressure and volume का क्या relationship है आपस में with respect to each other?
That they are inversely proportional to each other.
But what was the condition?
If the time is constant.
Temperature. If temperature of the
Oh,
body is kept constant. ठीक है. रेस्ट जो उन्होंने यहाँ पे कुछ थ्योरी डिस्कस किया हुआ है, आई कुड बेरली सी द वन, बट वी नो दैट थ्रू दीज पैरामीटर्स यू नो कि इफ देयर इज अ चेंज ऑफ कलर ऑफ अ सब्सटेंस we can say there is a temperature change. We cannot tell the value of temperature that is going on and matlab in that particular scenario, but we can tell by looking into this कि जी temperature change हो रहा है हमारे पास. किस किस थ्रू हम लोग आइडेंटिफाई कर सकते हैं फिजिकली, हम कैसे विजुअली कैसे आइडेंटिफाई कर सकते हैं? Expansions के through, if liquid started bubbling, there is a change of color और कुछ भी इस तरीके से है, through this we can easily say that the temperature of the body is जो है वो change हो रहा है हमारे पास. ठीक है. तो जो यहाँ पे change of colors, change of फलाना जो भी लिखा हुआ है whatsoever, तो all through that जो है हम लोग जो है identify कर सकते हैं temperature change को. जितना ज्यादा vigorous temperature change होगा, हमें एग्जैक्ट वैल्यू मैग्नीट्यूड ऑफ द टेम्परेचर को मेजर करने के लिए ऑल वी नीड इज द these devices, these apparatus to get the accurate value. Looking into these thermometric properties, we can only see the change. There are some changes occurring, but we cannot tell for sure कि values कैसे change होंगे. जैसे liquid crystals are those materials that change color with the change in temperature. ठीक है. Liquid crystals are packed inside a plastic strip. अब obviously उनकी color coding उसके हुआ होगा कि if this color is present, this means कि उसका temperature इतना है. अगर color change हमारे पास उसके respect से हो रहा है तो उसके हिसाब से हम लोग temperature का अंदाजा लगा सकते हैं. In these thermometers, a liquid crystal material is sealed in a plastic container or pouch. We touch it with the body whose temperature is to be measured. When it's temperature changes also changes color by matching the color to a temperature scale. जो मैंने आपको बताया कि calibrated colors होंगे, उससे हम identify करेंगे the change of temperature, वहां से हम अंदाजा लगा लेंगे क्या होगा. Resistance and वो बायोमेटालिक स्ट्रिप का मीनिंग मैंने आप लोगों को बता दिया है. बायोमेटालिक स्ट्रिप हमारी आयरन्स के अंदर लिखा होता है. If ever you have used or you have done the ironing of your clothes, you must have heard the tick tick sound always. After some time एक tick का sound आता है, and then the light of the iron stops, and then after sometimes it lights up again when you start ironing again.
yeah.
So बायोमेटालिक स्ट्रिप होता है, वो बायोमेटालिक स्ट्रिप की एक्सपेंशन होती है अकॉर्डिंग टू द टेम्परेचर. जब टेम्परेचर इंक्रीज करेगा तो वो एक्सपेंड करेगा और कनेक्शन ब्रेक हो जाएगा. When temperature will come to a certain value, it will become straight again और सर्किट दोबारा से ऑन हो जाएगा. Whenever we talk about the calibration of the calibration, हमारे पास basically ये होता है कि how we can set a certain values to the thermometer, और उसके अंदर से हम लोगों को आइडिया होता है कि किस तरीके से उन्होंने हमारे पास काम करना है. Calibration जब भी हम करते हैं, there are two points जिनको हम नाम देते हैं upper fixed point and lower fixed point. And lower fixed point. आप अपर फिक्स पॉइंट अगर आप वाटर के रिस्पेक्ट से डिस्कस करें तो फॉर वाटर अपर फिक्स पॉइंट इज 100 डिग्री C, boiling point of water, and lower fixed point is 0 डिग्री C फॉर दैट हमारे पास, ठीक है। अब हम लोग क्या करेंगे, इसको हम मेल्टिंग पॉइंट ऑफ आइस भी कहते हैं, and this is known as the boiling point. Up, we have studied the heating curves and cooling curves, or we have not done it yet. Have you done the heating curves and the cooling curves? Acha, remember this, whenever change of state is occurring now, temperature constant रहता है. For example, if solid is melting to liquid or liquid is converting to gas, the temperature would remain constant. Solid to liquid को क्या नाम देते हैं? Melting point. Liquid to gas को क्या नाम देते हैं? Boiling point. For a pure substance, whatsoever the material is, at melting point or boiling point or reverse condensation and what is the other point? Freezing. At these particular temperatures, at these particular points, temperature of the system remains constant. It does not change. ठीक है? So हम क्या करते हैं? First of all, we put the thermometer into the melting ice and we see the level of liquid. हम normal mercury in glass thermometer को discuss कर रहे हैं. We'll put the liquid, the bulb of the thermometer into the melting ice and we would see कि जी level of liquid क्या है. After that, we will suspend the thermometer over a boiling water and we will see the rise of liquid. For example, ये ice point जो होता है वो lower fixed point होता है and steam point हमारे पास क्या होता है, upper fixed point होता है. So जो liquid का total height होगा यहाँ से यहाँ तक, ठीक है. For example, it came out to be 10 centimeter. मैं उसको equal जितने टेम्परेचर में डिवाइड करना होगा उतने उससे डिवाइड कर दूंगा. फॉर एग्जाम्पल मैंने 100 डिग्री C के लिए बनाना है, तो मैं क्या करूंगा, 10 सेंटीमीटर divided by 100. I would get whatever the answer to वो किसको शो कर रहा होगा, 1 डिग्री C. ठीक है. बाकी सेल्सियस इन फ़ारेनहाइट के अंदर वो वैल्यूज अकॉर्डिंगली चेंज होती है. 0 डिग्री C इन फ़ारेनहाइट 32 के इक्वल होता है, केल्विन में वो 273 में होता है, एंड जो डिग्री C में 100 होता है वो केल्विन फ़ारेनहाइट में 212 होता है, एंड केल्विन टेम्परेचर में 373 होता है. थर्मोमेट्रिक सब्सटेंस क्या होता है? A substance through which we can identify the change of temperature. Thermometer क्या होता है? Device through which we can measure the temperature. Calibration of the thermometer क्या होता है? Through which we make the deviance on the thermometer in order to calculate the temperature of the device, जो भी जिस तरीके से मेजर कर रहा है. Am I clear about these points?
Yeah.
Okay.